Today we have Robbie Belson from Verizon with us, hanging out on HashiCorp Live. Robbie, how are you doing?
I'm doing fantastic. Thanks for having me, Rosemary. It's gonna be a ton of fun.
I know, I'm pretty excited. So tell us a little bit about yourself. What do you do at Verizon? Why are you here? Why are you talking about 5G?
Why are you here today? I mean, that's probably a good place to start.
Yeah.
Let's see. Well, I joined Verizon back in I think 2019, I think, and since then I have been leading our developer relations and experience efforts. So building DevRel from the ground up is definitely something really special, and no better place to do so at this really unique point of convergence between cloud and telco, or cloud and 5G. So specifically what we're going to be talking here about today is what does it mean for the cloud, particularly the cloud we know and love and AWS and beyond. What does it mean to actually bring that within the 5G network? And what are any compromises you might have to make as developers? But most importantly, how can HashiCorp help you abstract away those complexities so it's just fun building as you know and love? And so over the past, say, 2 years in leading DevRel here at Verizon, the usual. I run our corporate engineering blog, lead our developer newsletter, and I think my favorite thing I get to do is work with partners like HashiCorp, building cool things, talking about it, getting developer feedback, and then trying to do a better job of building that same thing again. And so that's a little bit about me and what we're going to be talking about today.
Awesome. You know what? I'm really excited that we got to chat. We've been collaborating back and forth on some of these Terraform modules that you've been working on, and I think what's been fascinating to me is learning about what 5G is. So, can you explain what exactly is Verizon 5G Edge and a little bit about what you're showing today?
Absolutely. So I think certainly all the hype of 5G aside, today is not just about the 5G network. Let's assume as a base case here, your phone, your mobile device, IoT devices are starting to emerge with 5G connectivity, even outside of Verizon, just at a high level. As you think about 5G, you're getting lower latency, higher bandwidth, increased security, things that are ultimately going to power next generations of applications. What that killer app will be, who knows? But you always want to have the network there for you prepared so that when you do deploy those applications, you have an underlying network and connectivity that can fulfill those ultimately customer needs. And so, as an addition, rather, or complement to the network, as an application developer today, we're always optimizing in my mind for that nth degree. High availability, we do so in corner cases. We're always optimizing for corner cases. That's what we do. I'd say over the past maybe, I don't know, 10, 15 years, we've always been finding new ways to optimize code, whether it's minifying your CSS or JavaScript, just take the space and shrink it so everything is smaller, more performant, more cost optimized. Everything also to CDNs, distributing what otherwise is static application resources and putting it closer to that end user. But as you think about the mobile environment, the CDN is no longer good enough, not only because you could even go closer to that end user, but also what if you could extend that model of the CDN to compute, not just storage, and heavier weight compute than just, say, your Lambda-like functionality. So with that motivation in mind, we teamed up with AWS to build Verizon 5G Edge with AWS Wavelength, otherwise known as mobile edge computing. Basically, it's another availability zone. We call it a wavelength zone. 17 cities across the US today, and you get those services you know and love. EC2, ECS, EKS, EBS. Services continue to grow. But there are some complexities or new sub-features that we're going to talk about today because mobile networking, as you mentioned, Rosemary, is not easy. And we're going to be talking about some of those complexities, but also how we team up with Amazon to abstract away those complexities. So it just looks like another VM. It just looks like another subnet. And we can actually use Terraform to make our lives even easier. And what we're going to be demoing today, we hope, is a little module that I built. So this is not a disclaimer. This is not Verizon developed module. This is just something that I built for fun over the past few days. I think really showcases that sort of convergence of 5G network intelligence, Terraform, and the underlying AWS wavelength infrastructure itself.
So, I did attach in the chat your talk, or at least the Verizon talk at reInvent, which
Cool.
has some of this information, right? Some more of this information. But what's been very interesting is that I'm not that familiar with what the edge means, right? So someone has told me, like, I work on this mobile application that runs on the edge. It can mean a lot of things. So, what does edge mean to you when you're speaking about it to folks today?
Absolutely. I mean, that's such a good question because there's no one right answer in my view. The edge can mean your device. The edge could even mean that radio tower you see as you're driving along the highway or in a dense urban city. It can mean the CDN. It could even mean the what I'll call the far cloud today, that parent region. So it really depends on what your alternative is. What are you benchmarking? To us at Verizon, when we say the edge, we mean the mobile network edge. My favorite way to sort of highlight this is let's give the only little bit I'm going to give you on 5G networks over the course of the next hour is I'll boil down the universe of maybe mobile network evolution into like 45 seconds.
Wait. Okay, wait, hold on. I'm gonna start a marker here because we might have to clip this for posterity. Like learn 5G in 45 seconds. All right. So all
Here's
right.
here's the shortest of takes that I think will help explain the answer to where is 5G edge? Where is AWS wavelength? At the highest level, say my phone is 4G or 5G connected. I'm consuming an app, doesn't matter. Assume for a moment I'm off Wi-Fi. So not just having a mobile device is enough. It's a mobile device connected to the mobile network. How does it work? Well, you connect to a radio, a 4G radio, otherwise known as an E node B, or a 5G radio, known as a G node B. To you, as the consumer of that mobile app, you don't really care where that traffic is going. You're just expecting a seamless experience. But nonetheless, here's how it's working. You connect to a radio. All of those radios in a given area actually converge to almost like a carrier data center. And in that carrier data center or aggregation point is where the packet core lives. It does all sorts of things. But one of the most important things it does in the context of wavelength is it has a packet gateway functionality, which is redefined in a 5G world as a user plane function or UPF. What does that do? Think of it as like the highway exit out of the mobile network to the rest of the internet at large. And so today, if you're going to the cloud, say US East 1, or I'm here in New York City, and I want to consume an application based in US East 1 in Northern Virginia, the highest level, I'm leaving the packet core somewhere in the New York City area. And then my traffic is going to eventually find its way out to the internet, all the way down through the internet, eventually make its way to Amazon into the US East 1 region. So now the question becomes, well, wait a minute. When you leave that mobile network, you can no longer control the reliability of that connection. Because as you hop around from point A, B, C, D, however many points there may be, there are routers somewhere. And those routers, at some points, can get congested. At some point of congestion, that packet can get dropped. And if it does, the client is forced to retransmit. What does that mean for you? Lower latency. Or rather, higher latency. That's not a great thing. So we figured, well, wait a minute. If a lot of the non-determinism is associated with the internet at large, wouldn't it be cool to bring the compute within the mobile network itself? You no longer have to egress or leave the mobile network. You can just put the compute right there. And I have a handy little diagram that should help explain where the edge actually sits in the overall picture. Let's see if I can get screen share working. Share screen. Let's see if this works here. So it should say in a second here where wavelength sits in the overall picture.
There we are.
Okay. Everything I just described should be captured here in some capacity, right? You have 4G and 5G devices. They converge to radios. Radios converge to packet core. Hop, 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 hop. AWS region. I'm no expert in animation, so humor me, but this is wavelength. Boom. See, all of those unnecessary steps are gone. Why? Because within that same physical location where the packet core lives, why not connect that to the broader AWS region, not going over the internet, which is, of course, best effort, introduce a new failure domain within AWS. So like availability zones, US East 1A to 1F as an example, you introduce wavelength zones as an additional failure domain. And then you connect it. So you don't have to manage this like silo that doesn't talk to anything else. But if it's part of your VPC, and it's just a subnet, then while these yellow boxes and these yellow boxes could be 1,000 miles apart, from the perspective of your console, you wouldn't know. That's the beauty. Resources can be managed from one pane of glass, from these carrier data centers, and the parent region at large. That's the idea.
That is really cool. I think that the graphic explained it really well too. Like it's for me it was sort of like, okay, there's all these disparate networks. That's effectively how the internet works. And to see that there's now an abstraction, a way for you to treat it as if it is almost one network is really amazing to me. I don't want to get necessarily into the weeds of how this is possible. But perhaps maybe we can talk a little bit more about AWS Wavelength itself. Is it a service that I can just magically pull up in the AWS console? Like, what does this look like whenever I decide to set up something that's like this carrier data center?
Absolutely, absolutely. In fact, for anyone in the audience tuning in, I invite you to go to the console and try to look for AWS Wavelength, and you won't find it. So I think it's like not G8, it may be private beta. All the above are not true. It's just when you think about AWS Wavelength, it's inheriting services that already exist. So while it is a new service in of itself, kind of like Outposts, it didn't actually need its own standalone section in the console because of the way it inherited existing services. And I think maybe the best way to break this down, we can also step through some key concepts of what is the same about Wavelength and what might be different. And specifically, what might be different, which of those differences make your life not amazingly more difficult, and which parts actually make your life more difficult. And don't worry, there's a solve here, but what are those solutions? So that's what we're going to go ahead and do here. While I pull up an additional set of materials, again, the key thing to take away is if you're familiar with an availability zone in AWS, a region has a series of availability zones, which are essentially failure domains that you can deploy different resources. Of course, you don't really know what those underlying data centers may be, but it's an abstraction in and of itself. So too are AWS wavelength zones. So you can think about wavelength zones as essentially zones within the Verizon carrier network corresponding to where this infrastructure is deployed. So I'm hoping you see some like map here with a bunch of cities. Think of this as high level and illustrative only. There are 17 wavelength zones around. And so at the highest level, Gov Cloud aside, AWS today, local zones aside, outposts aside, you have US East 1, so somewhere in Northern Virginia, you have somewhere in Ohio, somewhere in Oregon, somewhere in Northern California. This is not an or, this is an and. So you get that in addition to 21, or rather 21 total geographies, or 17 net new geographies where you can deploy your applications. Pretty cool, right? And again, no compromise from the perspective of the console. Same pane of glass, I could manage 21 EC2 instances or VMs in 21 different locations. And it just all show up right there because the wavelength zones are abstracted as just another availability zone. Meaning, when you go in the console and you look for availability zone ID, you'll see that it says something like US East 1 something WLZ, as you see here, US East 1 hyphen WL1 wavelength, the city code, WLZ wavelength zone, a number. So it's inheriting those same properties, and that's what makes it easy to use and why route tables are still fair game, subnetting is still a fair game. That's the basics for wavelength zones. Pretty cool, right?
Yeah, I will say that this tripped me up, and it was in a good way, in a really good way, because you were saying like it's so easy to identify or just use a wavelength zone. It was really easy because we turned it on in one of our AWS accounts, and I ran some Terraform, and I was a little bit too, let's say, a little too broad in my filtering of availability zones, and it included the wavelength zone. And funny enough, I was able to deploy like an entire like EC2 instance situation into a wavelength zone without realizing it. And then I was like, wait a second, what is the zone? I've never seen this before. I was like, oh, it's the wavelength zones. So for those who are wondering, like, this really that complicated? I'm just going to tell you, I accidentally used it and it was so easy to deploy without realizing that I was just using, I was using a specialized zone, right? So just saying, I have my own story on how easy it was because I didn't even realize I deployed to it.
That's exactly right. And I
Yeah.
think one important caveat is all of these 17 cities all have parent regions or regions in which they're associated. There's no such thing as an availability zone that isn't part of a region. Now, what might trip you up is that there's only two regions that they're a part of here. So the Chicago wavelength zone is a part of US East 1, Northern Virginia, and not US East 2, Ohio, even though distance-wise, perhaps Ohio could be closer. So, of course, you look in the console, key takeaway being US East 1 and US West 2 are where all of these wavelength zones exist today. That, I'd say, from a hub and spoke perspective, the fewer regions you have to stitch together, the easier it is to build geo-distributed applications. Just as an example, you're building some Kubernetes cluster. You don't want to have to do like cluster federation with different regions, peering. Everything is easier when it's in one VPC. So my guess is that is one reason in support of why you want to have as many of these wavelength zones within a given region. So I think that that's important.
Huh. That's good to know.
Um,
You touched briefly on this, but who's using AWS Wavelength? Like, who are the developers using it, and what are they using it for?
Absolutely. There's some really cool applications, I must say. Really, there's two themes that I think of for wavelength use cases. One, you value speed or performance rather above all else. Performance doesn't just mean latency, and I cannot emphasize this enough. It's not just you want to save X milliseconds. It could be that for whatever reason you want to maximize the size of that pipe or uplink between that device and that compute. Perhaps you're uploading ridiculous sized files for some awesome or crazy computer vision. That's going to be a great use case. It could also be from a reliability perspective. As you think about outages, again, failure domain. So you want this within the mobile network. You don't want to incur a latency or reliability penalty of leaving the mobile network. It could also be for a security perspective. Worth noting, this is a Verizon mobile edge computing solution. So if you're a non-Verizon mobile user, including a Verizon mobile customer connected to Wi-Fi, that connection is blocked. That's by design. So as you think about security, the internet-bound DDoS attacks will not surface in wavelength zones in the same ways you might see them in the parent region. That is a key point. So performance are a set of use cases that customers might leverage this for. Another huge flavor of use cases, and of course I'll give you examples here, but another flavor that I think is important to paint is when you want to move towards a thin client architecture. You needed all this compute on the device, but now you want to make that device cheaper, but you want the compute as if it were still on the device. So by disintermediating that purpose-built hardware, it's like you still have that compute on the device, but it's ever so slightly topologically remote. And so to give you a few examples of what that might look like, perhaps working backwards, imagine some sort of robotic fleet that needs to collect important sensor information about large crop fields. And if a particular robot noticed something anomalous, you wanted to make a decision in real time. Today, you couldn't do that because those robots may not even be connected to cellular devices. And worse yet, they're collecting all this data on the device that someone after the journey has to go walk out there, extract the hard drive, eventually go upload it. That's OpEx. What if you could do away with that OpEx, attach a modem to these robots, not only have them potentially communicate with one another, but have that data uploaded to the edge to aggregate not only with maybe that one field, but multiple crop fields in a given area to do all sorts of real-time analytics to then send command and control signals back to those devices themselves. So think about the future of agrotech, particularly, again, thinking of things that are outside. I think that that's one really cool use case that we're certainly exploring. But to give you more concrete customer examples, I'll throw two at you. Streaming, low latency, performance are often, say, closely linked or inextricably linked. One really cool customer, Summit Tech. Imagine all the apps you like. Take a streaming app you really like, FaceTime, chat, and then your favorite retailer or commerce platform. Imagine if those were all in one app. Pretty hard to do today, right? Because the network and there's challenges with having all of that compute. Is it on the device? Is it offloaded? What is the impact to performance? Put that all in an app, one app, without compromising on that experience. And oh, by the way, turn that video stream into the lowest latency stream out there from source to destination, and let you move around with the app and have it fully 360. They've been doing some really, really cool concerts, and you can check out their app Audience on the App Store. I'd say that's one of the really, really cool customers we've seen. One other I'll throw at you, Atho. They're an XR company, and they built an app called Beam. Their goal, among many other things, is to bring XR telepresence to the world of healthcare, to universities, to any time, like here. I'd love to meet face to face, but here we are on Twitch. But what if we could both wear Magic Leap or HoloLens and be within the same room, so I could see you in this 3D space? We could even draw within 3D space. We could upload all of these 3D objects, reference architectures, even code that we could step through. That's what they developed today. And one really cool use case is when students are touring universities, be it either the pandemic or just excessive costs, you don't have to go visit anymore. Just go into this XR space, tour from the comfort of your living room. And if you're the university, whatever incremental cost for wavelength you may incur is recouped by the fact that more students are applying to your university. So one of the key takeaways, I think, for people tuning in is this is not technology introduced for speed for the sake of speed. This is technology introduced, in my mind, because speed will provide incremental, or performance rather, will provide incremental value to your business. And that's one such example.
That's awesome. That's really cool. So basically, you're telling me we could be in the Matrix. Like we could just, and all thanks to AWS Wavelength and 5G Edge and everything here, it's actually pretty interesting. I feel like we could be using AWS Wavelength and the Verizon 5G Edge network without knowing it, because here we are streaming, right? And who knows? I don't actually know what's running underneath this, so I can't say, but it's very fascinating to know that this is a possibility. So that's actually super helpful. Now, I imagine that this may or may not be that easy to deploy, right? Traditionally, networking has induced a little bit of fear when it comes to automation and deployment, and there are usually challenges and limitations. Nothing wrong with that. Just sometimes there's some obstacles to fully automating it or to deploying it. So can you describe some of the pain points that you had or some of your customers had with infrastructure deployment, and how you ended up kind of getting into Terraform of all things? Like for me, I wouldn't intuit Terraform with 5G related networks and Amazon.
Absolutely. I'm laughing here because I'm looking at the chat with Cole with all caps 5G. Love the enthusiasm. Please keep it up. We encourage questions, comments, all of the above. But yes, complexities around networking and mobile networking. So the reality is that I'm fairly certain, Rosemary, I agree with you that when you launched accidentally wavelength zones, it sort of just worked. What I'm fairly certain didn't work is I doubt that the networking was set up that you could actually communicate with that instance from the mobile networks. Within the VPC, you're good. Outside of the VPC, if I had to guess, that VM could talk to nothing because the carrier connectivity wasn't cared for in that automation. So what do I mean by that? So when we think about connectivity today, parent region, if you want to talk outside of the VPC, and we're not talking about some like peering scenario or hybrid connectivity scenario, but like your normal, like you want to expose an app to the internet, how might you do that? At the highest level, that VM or resource needs a public IP, needs to be exposed to the internet at large. And again, security groups and knuckles aside, we're just trying to boil it down, make it simple here. And then you need an internet gateway. You need to NAT the traffic all of these private IP addresses that are scoped, and then you have this logical isolation for your VPC, and then translate those addresses to whatever public IP was allocated and attached to that resource. Well, hate to break it to you, in Wavelength, similar concept, but you can't attach a public IP to these Wavelength resources because from a networking perspective, it wouldn't work. Remember, it's within the carrier network. So you can't use a generic Amazon public IP because it wouldn't be delineated or scoped to that geography. It's really almost Verizon addresses corresponding to each of these points within our network, but exposed through the AWS console. So that's what a carrier IP address is. It's a Verizon carrier reachable IP address that you can assign to wavelength zone resources. Again, you can have a private subnet in wavelength, no problem. But for public or carrier subnets, you need to attach that carrier IP. But now that you did that, we have to work backwards and say, well, wait a minute, now the internet gateway doesn't work because it's a different type of NAT. Now you need something called a carrier gateway. Again, sounds scary, and it is scary, but Terraform makes life pretty easy. And I think that that's really what motivated me to consider Terraform for a lot of the infrastructure templates we were developing for customers. We wanted to make it as easy as possible. And we wanted a platform that could deeply support wavelength and allow us the opportunity really to just fail fast. And when things break, not have to just destroy the entire template, but just taint a resource until I finally get it right. So if being completely honest, what I love about Terraform more than anything is the ability to taint specific resources and just keep trying until you get it right. So big thank you, Rosemary, to you and your team for making my life awesome. But that's what we're going to talk about today. So the complexities around carrier IPs and carrier gateways, and even the wavelength zone subnet as a concept. How do you use Terraform to care for that? And then secondarily, we're going to start to introduce the concept of, we just introduced 17 different cities that have nothing to do with DNS, but you want to use DNS. So how do you know where to go and when and why? And does that go into Terraform? That's what we're going to talk about.
It's going to be very interesting. Just one note, maybe if I don't know if it's a question or something you can comment on, but someone did mention it's a bit painful that things like neighboring wavelength zones not being able to speak to each other.
That is a great point. And you know what? I share that pain. In fact, I found out about that accidentally a few months back. As you think about wavelength, it was always designed as a hub and spoke architecture. In the same way that all of these zones have a given parent region, well, that was designed in such a way to block, essentially, communication between each of these wavelength zones, with an exception. If I'm in Boston and I want to talk to New York City, they're both edges, they're both part of US East 1. It is true that they cannot connect to one another within the VPC. Now, could you have some proxy in the parent region relaying traffic? Knock yourself out. But if you try to address VM1 and Edge 1 to VM2 and Edge 2 via private IP addresses, they don't work. However, via carrier IP addresses, so out the carrier network, it does work. So the caveat to the question in the chat is wavelength zones can talk to each other. They just cannot talk to each other within the VPC, only outside of the VPC via carrier IPs. So that's a good point.
Good to know. Okay, so we talked a lot. We had to set up the stage a bit because a lot of us may or may not be familiar with some of these things. So why don't we just dive into the Terraform? What are you building today? What are you using Terraform for?
Yep.
What is it helping with?
Absolutely. I'm going to try to demo how to use Terraform in I'm not going to call it geo-redundant, but geo-distributed AWS Wavelength deployment. So VMs in a bunch of different wavelength zones, showcasing those basic fundamentals of how Terraform already supports AWS Wavelength. You just didn't know it, you being the general audience here. And then I want to show a little module that I created that uses the Verizon Edge Discovery Service to help you basically create a service registry of all of these edge endpoints. And why that's important is that if you were to look up any of these carrier IPs in a geo lookup tool, they'll never get it right. They'll be completely wrong. In fact, you'll look up something like DC and I'll tell you you're in like Kansas City. If you don't believe me, try it. And so we developed a service because of our network intelligence. We know topologically where you are. It's not relevant geographically where you are. Believe it or not, you could take a road trip from Boston all the way down to Miami. And if you didn't turn your phone off, closest edge is still going to be Boston. So this is very much like the airplane. If you think about like airplanes, closest exit maybe behind you, like totally freaky stuff that you need network intelligence from Verizon to help you work through that. But I don't want to have to manage this rogue infrastructure that doesn't talk to anything else. So I built a Terraform module, has a bunch of Lambda and lifecycle events. It basically takes any time one of these VMs is spun up, it will figure out what that carrier IP was and populate it into this service registry. And if you want to learn more about the nuances of the Edge Discovery Service, you can check out our reInvent talk that I believe Rosemary popped into the chat, but I really want to focus on the Terraform fundamentals here. That's exactly what we're just talking about here. There's a lot of stuff to do. What if there's a better way? Boom, Terraform makes life easier. So maybe we quickly just walk through right before the demo, just like key code snippets that are like really important. And then we're just going to try to break things and see what happens. So,
our favorite thing.
yeah. I'm calling on you, Rosemary. Like
I know.
if things go wrong, I'm gonna need a co-pilot here.
Yeah, you know what? Like this is what happens. It's like we deploy on Fridays, right? Something's gonna break.
Exactly. So let's talk about the first thing you do in Wavelength is creating a wavelength zone. And we talked about that a wavelength zone is really just inheriting many of the properties of an AZ or availability zone. That's why what you're seeing here, when you create that wavelength zone subnet, you're really just creating another subnet. And the only change is that availability zone attribute, where you typically put something like US East 1A. Now it's this slightly longer string. Of course, corresponding here, BOS, Boston. And as long as the wavelength zone you put here is in fact a wavelength zone part of that region, this will work. So if I'm in US East 1 and I try to put in like LA, not going to work. The configuration won't be supported. But within those bounds, this should work fairly nicely. That's concept number one that you're going to see in the Terraform module that we created. Piece two, carrier gateways and essentially the routing tables. So when you create a route table is a route table. So I skipped that resource because there's no difference there. But when you create a carrier gateway in Terraform, all you need to do is of course, it's a new resource here. So this was introduced to the AWS provider by the Terraform team. So thank you, Terraform team. All you have to do is specify the VPC ID. That's it. All of the like crazy carrier natting stuff, totally abstracted to the developer. So much so that even though these are physically distinct geographies, right? You could have deployments in Boston, New York City, Miami, Atlanta, DC, Chicago, one carrier gateway. How's that even possible? There's obviously some physical hardware somewhere downstream taking care of this. But to you as a developer, just works. Why deal with that complexity? You don't want to. It should just be one carrier gateway, one route table for all of your carrier subnets. Well, that's what we did. And so I think that's huge, right? That's crazy. Because before, it makes sense that you'd only need an internet gateway, one per VPC, because all of these failure domains were very, 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 very close to one another. But in spite of that, when you don't have that luxury, it's still that seamless. I think that's incredibly powerful. One other thing I'll add here is when you create a route table, there's a new attribute here when you want to create a default route through this carrier gateway, much like you would with an internet gateway, where you just specify that the resource ID of that carrier gateway. Key point.
It's really cool. I wouldn't otherwise know that this is like something special, right? A gateway, because gateways in AWS are, if you've done VPC work and VPC configuration, gateways tend to be, I guess, a standard term, right, for what you're going to set up. So for me, this is very intuitive, knowing the AWS constructs and knowing what I do and do not need to set up. We have a question. I don't know if you can answer it now or if you want to hold off. So I'll leave it up to you, but I'll ask it. What about 5G features? For example, network slicing and NEFs, network exposed functions. How do we use them? I guess the question is, can you use them? And can we manage them with a Terraform provider attached to the carrier IP of the wavelength zone?
That's a great question. And as we think about that journey to everything discussed here, the Verizon Edge Discovery Service is one such piece of network intelligence. I wouldn't say it's a 5G feature per se. It's an extension of underlying 5G network data that we expose as an API that you could use as your own standalone Terraform provider. But for now, what I've done is I've created an abstraction layer using a bunch of Lambda and lifecycle events to leverage that 5G data. So we're going to talk about that. But the idea being here, absolutely, that today I wanted to talk about not just, the AWS Wavelength service team could come on here and talk about AWS Wavelength. I want to also talk about this edge discovery piece, which is ultimately a component of the unique topology of the 5G network and how developers can use it today. So that's a great question. One last thing that I think is worth mentioning, 2 ways today to create a carrier IP or attach it to an instance. I'm pretty sure when you create a when you create a VM in an availability zone in the parent region, there is an attribute somewhere to just attach a public IP. I'm pretty sure you can do that. There's also an option to attach an elastic IP. And of course, that's intentional to developers because in some cases you want an ephemeral IP that dies alongside the VM whenever its time is up and the resource is terminated. And in some cases, you may want to have a static IP that you don't want to change because it's corresponding to a load balancer. And something is taking care of making sure that that elastic IP is always being switched out for healthy VMs. So that's just how things are, of course, work today. Wavelength inherited the latter piece, the elastic IP. So I can create a carrier IP address for any of these wavelength zones. When I look at network border group, that attribute, I had no idea what that was before I started thinking about wavelength. All a network border group is, in English, pool of IP addresses corresponding to a given geography. So in this case, give me an IP address in this like Boston region. And then now that I have this IP address, please attach it to whatever instance ID I want. So the resource attachment is entirely the same. The only difference is that under network border group, that attribute, you would change out the wavelength zone. Now, one other way you can do this, if you wanted the feel of attaching a carrier IP that was ephemeral on launch, you can't do it using the AWS instance resource, but you can using an AWS EC2 launch template. So there was a field added that was something like allocate carrier IP or something like that. And you just set that to true. And so the launch template has a carrier IP associated with it such that when you create an auto scaling group, that carrier IP just pops up. That's the idea.
Okay. So just to quickly summarize, if you are trying to attach an instance to this, if you have a EC2 instance resource, you have to allocate effectively a static IP before you can access it. Versus if you do want more dynamic IP address assignments, you would have to use an auto scaling group or launch template.
That is exactly right. And
Okay.
more information here can be found in our 5G Edge tutorials repo. So github.com/Verizon. You go to the 5G Edge tutorials repo, and we have a subdirectory for Terraform. Now, all of these are not on the Terraform registry yet. They're sort of in preview stage. We'd love to get your feedback, but over time, we're going to start to move these to the Terraform registry.
Cool.
So just a quick update on that.
Awesome.
Alrighty.
All right.
Time to break things?
Yeah, let's break things.
Oh boy. Okay.
No, don't worry. If it doesn't work, it doesn't work.
Let's do it. Let's do it. Let's have some fun. Okay. I want to explain. Well, let's first start with. You can see my screen here. Let's blow it up a little bit, make it easier to read. Let me know when we like the size of the font here. Bigger?
Maybe even more.
Okay.
Like one more. Yeah, that's probably better.
Okay.
Yeah, that's good.
To
Okay, I'll move us
simulate-
down.
Perfect. To simulate. Oh, we got one more. I think someone wanted it one more.
I think we're good. I think we're good.
Okay, great.
There's a delay.
So I'm using Cloud9 here. I like it because I can divide my screen in half. The bottom half of the screen I'm going to use to simulate as if I was using a mobile device, because everything we're going to try to do now isn't just to deploy the infrastructure. We're going to deploy the Edge Service Registry. So with all of these carrier IPs that are allocated, we need the Verizon Edge Discovery Service to keep track of them so that if I'm in New York City, we hope it responds back with New York City. However, if it responds back with something else, that doesn't mean it messed up. That means something in the network and the topology is such that, remember, closest exit behind you, it can come back with something else. So That's how we're treating this. Think of the top half of the screen as all the infrastructure I seek to create. The bottom half being anything I want to do to interact with the mobile device to see if, in fact, this worked. That's what we're doing. So let's talk about what we did and what we didn't do. So in this 5G Edge tutorials repo, I'm taking a look at my EC2 or AWS EC2 module that you can't find on Terraform registry yet. What do? We start with initializing the Terraform provider, as you can see here. You can also see that we initialize the AWS provider. From there, for now, a few things. Maybe we'll actually take a look at the variables file just to show you how we attempted to make this repeatable. The first thing that we did is, of course, you have the profile or AWS credential profile region. We're trying to scope this down. So if you try something crazy outside of a Verizon wavelength zone, we won't let you, at least in this template. And then for the purposes of this demo, just to keep it as simple as possible, you can choose two different wavelength zones. They could be the same, but to try to showcase something interesting, the idea would be that you would select two different wavelength zones, and I'm trying to use conditional validation to make sure that in fact you use a wavelength zone that's in fact real. Now, open question to the Terraform team that it didn't occur to me exactly how to do, so I'll just throw it out here. What I would have loved to do is say, okay, based on the even more conditional validation. So what I've done is I've said, okay, here are the universe at the time of like 10 different wavelength zones that you could choose from. But if you've selected a region, then you can't choose from all 10. You can only choose from those within a region. So maybe my question to you, Rosemary, would be, how would you refine this so that based on the region, I could further scope this down? Based on what you put for the first variable, that then informs what you do for the second variable.
So I don't think there's a way to pass, in at least the variable validation conditionals. I don't believe there's a way to pass other variables outside of the one that you're locally scoped. So I will definitely talk to the team on this one, but if you have a separate region, you won't be able to pass that at this time through to variable wavelength zone, right? Some folks do external validation, which is also the case too, or they do a map, right? So it's a very opinionated map. And so, for example, someone chooses the region, they may not need to choose the wavelength zone, and then you perhaps choose the zone based on the region, right? So you could do it in a couple different ways. I think some folks may have some suggestions in chat as well, but usually the kind of my approach to this is be opinionated, set a map of the region to the specific set of wavelength zones, and determine which zone is best, unless someone overrides it. Like in this case, there's a default and someone decides to override it.
Got it.
Yeah.
It's good to know we didn't miss anything crazy here, and we'll definitely take that feedback. But again, looking at variables, so you would choose a wavelength zone. We have a great question here from Taylor around reference architecture, so we'll circle back to that in a second here. You choose a wavelength zone or wavelength zone ID. You choose a second one. So I'm here in New York City, so I chose Boston as one, New York City as a second one. And then I also put in a bastion host just for best practice. So if we think about, again, the connectivity, if you can only reach it from a Verizon mobile device, then when you try to SSH in from your laptop, it's not going to work. You can say something's broken. We've all been there.
So just to clarify, is the bastion in the carrier network, or where is the bastion?
The bastion is in the parent region. So we created a subnet here, or we will be creating a subnet in this availability zone in US East 1A. And then that bastion host, we expose port 22. So you SSH into the bastion host in the parent region, and then use that as a jump box to jump onto that wavelength zone. And because they all talk within the same VPC, it works.
Okay.
That's the idea. Now, one thing I'll mention for all of you who've memorized all 397 some instance types on AWS, there are 4 on wavelength today. Not instance families, instance types. There are 3 instance families available, the T3, R5, and G4 family. Bunch of jargon typically, but I'll break it down as T3 being general purpose, R5 being memory optimized caches, DBs, etc. G4 being your Tesla, NVIDIA GPUs. That's what's available today. So a lot of the use cases today that are compute heavy, probably using G4s. But for the purposes of this demo, cost efficiency, we're going to be using our friend, the T3 Medium. Create a key pair. And then I will say I created we have a conditional resource that's created based on whether you want the bastion host. So if that's set to false, no bastion host is created. One of the only Terraform tricks that are probably used in this, but nonetheless.
What? You use conditionals too, so you know what? You're pretty good so far. You're pretty good. The toggle, we all appreciate a toggle.
Now, let's go to outputs here. These are fairly important if you wanted to actually access these resources. I added the bastion public IP, so this would be the IP address that you would SSH into. I've also added as an output the wavelength private IP and carrier IP. So that's really cool. Now you'll notice that there isn't the second wavelength carrier IP. I was quickly whipping together, taking this existing module that only had 1 wavelength zone and recently added 2. So you don't see it here, but of course we could add a second output for the second carrier IP. Take us 2 seconds. But nonetheless, before we deploy this, because order does matter here, I want to start with the Edge Discovery Service module that I built. I try to call it the EC2 data plane API, and here's why. For those of you who love HA Proxy and who use their data plane API, what it essentially is doing is it's hunting for tags. And then based on that tags that you preset, that's how it knows the targets for your load balancer. So then I'm like, okay, that's kind of cool. Couldn't the Edge Discovery Service also use a bunch of tags? So when you tag your application, only the VMs with a particular tag will in fact be registered to this service registry. So how would I know whether a VM is created? Well, I could use event bridge rules anytime a resource is running, an EC2 or VM is running or destroyed or terminated rather. And then that would trigger a Lambda function to go pick up all of the active carrier IPs that have a particular tag in mind and then go deploy it. So one thing that we need to look at then is, did I tag my instances and what did I do? So what I did under my handy dandy tags here, and worth noting in the other modules you'll see in this Terraform registry, I have individual files for network, VPC, route tables, VMs. So this is, I believe this isn't best practice, but our practices have definitely evolved over time. This is a key tag though. So this Lambda function is always looking for, this is the tag name, EDS, Edge Discovery Service, EC2 plugin app name. And then within the, as a variable for this EDS module, it's defaulting to wavelength-app, but you can go ahead and change it. So if we look here at eds.tf, you'll see it's a bunch of things. You'll see here my access key and secret key. Please, please go steal them. We would love for you to go. There's no like utilization-based billing today. We would love for you to use these keys and build.
Bold claim. Goodness gracious.
Bold claim. I'm opening this up to the world and I'm proud of it. This is the idea. You choose the region and you use it access key and secret key here. And feel free to follow along with me. We encourage it. So again, you have the module, the source, the version, the region, the access key and the secret key. And then in this additional line, you would add in an optional tag. That's the idea here. So we're going to go ahead and do. So I will not be exposing my AWS keys on this call, but I will be exposing our Edge Discovery Service keys, just so people can understand that there are keys associated with this Edge Discovery Service and they're not hiding in some secret.tfr files. So let's see here. Assume this works, which is the first dangerous assumption I've made in this afternoon. And hopefully things just start working. So
while it runs, I do actually have a clarification in the chat. There's a lot of questions coming on, but there is a clarification. I just wanted to make sure we were clear. Which network is the Lambda function running in? Is it the parent availability zone? Is it in the wavelength zone?
Great question. Lambdas, you pick a region, and because all of these wavelength zones are also part of a given region, they're one and the same. Said differently, all of these resources are being deployed in the Northern Virginia region, even though we have wavelength subnets in Boston and New York City. It's still that Northern Virginia region. Similarly, Lambda, that Lambda function that I created that's being targeted or rather triggered by a CloudWatch event or event bridge rule, is in fact also running in US East 1 or the parent region. So there are a lot of functions that wavelength zones inherit, like VMs run in the actual physical hardware within the carrier data center. Things like CloudWatch, things like auto scaling. Some of that functionality doesn't actually live at the edge. It lives in the parent region, but controlling aspects or ingesting data from the edge. That's the idea. That's a great question.
Got it. So, and just to make sure, is the Lambda function attached to a specific network, or you're just kind of like, let it run, and then it's using the region's network, sort of a predetermined region's network?
That's what I think I did. Let's remind ourselves.
We could break it, let's just run it as like a true Lambda. No network dependencies at all.
What's the fastest way to find the underlying? We have time, right? Let's quickly look.
Yeah, we have time. So if you had the Lambda, if you could bump up, it up even more.
Okay.
Let's see. There's the Lambda. Lambda.
IAM roles.
There we go. Function name. I see the function.
No. So it doesn't need that. It doesn't need a network to extract metadata about the underlying EC2 instance.
Okay.
And yeah, it doesn't.
Okay.
Yeah.
Yeah. Okay. So let's summarize. for those who are following along. The Lambda itself is not directly connecting to any of the EC2 instances. Its main permissions require I assume describe EC2 instances so that it could retrieve tagging information. So as a result, the Lambda itself does not need to be associated to a specific subnet to run. It just is retrieving information about the tags, and I guess the Edge Discovery Service is publicly available, right?
It's publicly available.
Okay.
However,
Yeah.
looking back here,
Mhm.
while you would only need to attach an IAM role that gives you EC2 and VPC access, read access, this Lambda function does need external connectivity because it's invoking the Edge Discovery Service. So at
Okay.
the highest level, just to run through what this is doing, there are a bunch of parameters that it's getting from SSM based on the variables that you provided in Terraform, including things like our service profile and service endpoints, the basically registry identification information. And then it's going to use that, figure out everything in this universe within that region, within the wavelength zones that themselves have a carrier IP. And assuming the tag is in fact matching, i.e., the first thing we do is we only describe instances that match those tags, take all of those carrier IPs and populate the Edge Discovery Service accordingly. So the takeaway here is that Lambda does need internet access today.
Got it. Are you okay with one more question that might not be Terraform specific, but
Yeah.
it's an interesting one? All right. What about roaming users? E.g., I have a gaming service and a user base that has access in the US now when using Verizon network. When they are on mobile roaming data, are they also able to see the carrier IP and locally break out to the MEC wavelength zone, or do they need to get routed back through the home network?
That is a great. Where is this device right now? Is the device a Verizon mobile user connected, like to some other country?
I believe they're in the US and they're using the Verizon network.
But
And then
they're
when they're on the mobile roaming data, so I assume that would be in another country.
right. So that's a great question. I don't know for certain. What I can say is Wavelength is a global service. So there are other carriers that are using this. If you go to the AWS Wavelength website, carriers like Vodafone, SK Telecom, KDDI, there are a number of other carriers who are building this out. So I would imagine that if you're in a country that supports wavelength zones and roaming on that carrier, it would appear to me as likely that you would connect accordingly. But I don't believe you could, nor would you want to. If you were in another country, you wouldn't want to go to connect to a wavelength zone in a different country. Of course, you would just want to go to the region. So if you were in the UK somewhere, forget wavelength. What I can definitively say is you are much better off going to some EU region over a wavelength zone back in the US if you were overseas. So that's a great question. I will say that there's the comment in the chat here from Eric. Lambda needs to be in the parent region availability zone. Absolutely. So there are a lot of services, as I mentioned, that don't exist in wavelength today. But what I always find fun is how you can connect the wavelength to the non-wavelength and sort of make it very seamless. And look, okay, our Edge Discovery Service module thing has been created. So what should happen is we should go here and see a bunch of parameters with nothing in them. In particular, we're looking for the service endpoints ID. So that no identifiers, we want to create a service registry, but the service registry doesn't exist yet. So if I did this correctly, that value will be blank. Great. Here's where we start to pray. We're going to apply this Terraform module here. I will say that this Terraform module doesn't work. Rosemary will help me fix it. And then we'll bring it all together. So a bunch of things that are going to be created, and we'll go into the console to see what's being created here in a little bit. But the idea being here that as these instances come up, when it realizes that, and it could be absolutely unrelated to wavelength. Every time an EC2 instance state changes to running, it will trigger this Lambda function to go scour that AWS universe with that set of tags that you provided, looking for edge resources matching those tag filters. And when it does so, it will update that parameter here with a legit service endpoints ID, which also conveniently happens to be the output of this module. You could then tie this into all sorts of use cases. So in this case, one of the carrier IPs is 155.146.4.195. Quick, handy trick. 155.146 screams Verizon carrier. You'll notice that theme pretty much nationwide. So it's almost like Verizon has its own VPC, if you sort of squint. But it's a handy way to know carrier IP. And we've seen that being consistent across the wavelength zones today. Let's go into the console just to quickly look at a few things here.
Can you increase the console just a little bit?
Of course. You'll see I had just like a bajillion hosts there.
I know. There we are.
Sorry.
Thanks.
Okay, so a few things that I want to highlight. So there's a Bastion host here. It's running in US East 1A. But remember, I told you that wavelength zones are really just an extension of the availability zone, which is why you see NYC and Boston here. So this is the New York City wavelength zone. This is the Boston wavelength zone. The VMs are still initializing, but nonetheless, while initializing, you'll see they got public IPv4 DNS names, even though they're not really accessible by the broader internet at large. However, this would be addressable within the Verizon carrier network. And you'll see that it got attached on Elastic IP. So again, 155.146. So you'll see that it's inheriting all of the things you know and love. And quickly, while we're waiting for things to boot up, under networking, let's inspect a subnet to see all the craziness of the carrier gateway that really isn't so scary when you start to look at the management console here. Again, with a bunch of Terraform, we didn't have to touch the console, so yay. Less human error. And when we inspect the subnet, you notice right now, it doesn't present to you as any weirder than any other subnet. It still has a CIDR and part of a VPC in the route table. You'll see here, local route talks to the rest of the VPC. I was in a /16 subnet, so it's just the default route, goes through the implicit router. And then all of your other traffic, or that default route, rather, so this is the local route, this being the default route, everything else goes out the carrier gateway. So it would be the same thing for an internet gateway. Of course, this would say IGW-alphanumeric string. So very, very, very similar. I think that should be the one takeaway. If you take away anything from this, one, wavelength is cool. Two, wavelength builds on the fundamentals of cloud networking and compute, particularly on AWS. Let's see. Moment of truth. One of them is up.
I see the status check.
Now, I'm not sure lifecycle events actually need the status check to complete. They just need the instance state to change. So what we want to inspect now, if this worked, we want to refresh this and see what happened. Man, the browser is playing games with me right now.
I know, it's thinking. It's thinking. Must be connect. Are you sure you're not on a? I told you, it was magic. It was gonna be fine.
In the 11th hour. Okay, wow, that was a lot of pressure by the browser. So what just happened? To extract or to zoom out here, this is the service endpoints ID that was created auto-magically by this Lambda function that was sniffing for carrier IPs, of which it populated these two 155.146 addresses. So why do we care? We care because if I was a mobile device, so I'm going to go to a little script I made, a little SDK leveraging the underlying edge discovery service. Remember, there's two operations: populating a service registry, and then saying something like, hey, I'm a phone. What is the closest edge to me? So to simulate that experience, of course, I'm not on a mobile device here, but this is the real mobile device of my iPhone.
Okay, so now we know it
exactly.
is. It's
the way it works,
your
basically,
iPhone.
it's like sort of like DHCP. So if I go on airplane mode and then reset, it'll just change. Worth also noting that from a wavelength zone, you can't ping a UE. You can ping a wavelength zone, but it is a bidirectional traffic flow, but you cannot initiate a connection from a wavelength zone to a phone. So for all of you thinking that can SSH into my iPhone, I guess you can try it. I don't think anything will happen. But what I want to show you is this. That's not it. That's a Google Docs. All right. That's not what we wanted. That
Yeah,
is actually my HashiTalks presentation. So for all you wondering what that Google Doc is, you can tune in next week to figure out what on earth that Google Doc is. Let's try to copy paste again. Oh man, does this normally happen in live streams, Rosemary?
Yeah, it
How are we
does. Don't
doing
worry.
overall? All
Pretty
right,
typical. Don't worry. We're good, you
fantastic.
know?
All right, so what is this doing? I created a very simple method that basically says, hey, I'm a phone. This is my IP address. What is the closest edge to me? And again, to further elucidate how not sensitive these keys are, you need keys to hit the service registry. It's not like you can just resolve an FQDN. You need the keys to also connect with it. So keys are certainly less sensitive here than, say, your AWS credentials, as an example. So we're going to go ahead and run this again. My iPhone, somewhere in New York City, it's going to authenticate to EDS. Did it, folks. New York City. So what did it do? All sorts of magic, fully automated. On the back end, all of the resources we created were auto-magically populated in Verizon's Edge Discovery Service. And then from the mobile device, it knew that the most optimal edge to me was the New York City wavelength zone. I'm in New York City. There's the carrier IP address. Folks, we did the demo. Thanks for sticking with me. We did it. That was a lot of fun.
That was a lot of fun. Thanks so much for going through. I'm glad it worked. You know, it is very standard for demos to just go horribly awry. So it worked. I mean, I guess it just goes to show, you know, it's very reliable. This is why we should all consider 5G.
That's exactly right. But we
Or at
can't
least
end
start
on that
using
note.
it.
We got to have some sort of like conclusion. Like how do these
Yeah.
things typically close out? What do
Well,
people want to know?
you know, we kind of have a couple. I mean, I have a couple questions.
Okay.
And you know, and then we'll close out and then I'll go do a couple plugs. But uh, does this work with Kubernetes, right? Because we've heard a lot from the Kubernetes community about edge computing and there's a lot of interest in it. So does this work? I mean, I assume because Amazon has EKS, this may or may not quite work the same way.
Absolutely. So the way you can think about EKS, yes, it is supported, but of course there's a but. Of course there's a but. The but is that the control plane is actually still in the region. As you think about low latency, the whole point of wavelength, it's not you're moving the universe of your applications to the edge. You're decoupling applications so that select functions can live at the edge. So while it's important to have a stable, reliable connection to the control plane, because we talked about that service link, that these edge zones actually do connect to that parent region via fiber, so a service link. It's fine if the control plane, to connect to it, you have to go from one AZ to another, from the edge back to the parent region. So each of these nodes or node groups in each of these wavelength zones are themselves basically geo-distributed. So Fargate and managed node groups are not supported in wavelength today, but you can run self-managed node groups in any one or number of wavelength zones and have that connect back to the EKS control plane. And that's the reference architecture that we've used today. So if you go to our Terraform subdirectory, you can launch the EKS template there.
And someone did ask about reference architectures. Are they all in the Terraform subdirectory?
Depends what we mean by reference architecture. They are reference infrastructure modules. As we think about reference architectures, like actual diagrams, one good place to start as you think about Kubernetes specifically, I'm going to try to find the blog here on the fly. One of our DevOps teams did a really, really cool piece. Basically, they were some of the first ones ever to talk about EKS at the edge. And they have a bunch of really, really cool diagrams I'd love to post here. Perfect. Here we go. I definitely take a look at this blog article. Let's see if I can paste in the chat. I can send it to you, Rosemary.
Yeah, I'll drop it into the chat.
So that's how you can find out reference architecture about EKS. Another great place to just understand reference architectures in general is the reInvent video that was posted earlier, or we host immersion days, often with AWS, pretty much once a month. And you can go to our Verizon 5G labs, just Google it. Lots of virtual events. All of the events have been pre-recorded, or rather like they're available to stream from the comfort of your home in addition to live events. So no shortage of training to get to take a look at reference architectures.
Oh. And there is another question, and then we'll close out. So last questions. Anybody who wants to get them in now. Okay. So the carrier IP looks like a public IP, but only routable in the Verizon network. However, as you can ping the carrier IP from the UE or mobile, that does that mean that the mobile data from the phone is still behind a carrier NAT router? That's the first question.
That is a handful. I think the way to think about this is the beauty of wavelength is that there's just a great abstraction going on. So regardless of the intricacies of what sort of physical hardware and routers are happening at the carrier level, what you care about as a developer rather, is you have a mobile device connected to the Verizon network. You can absolutely initiate and ping these wavelength zones, and the application, as you think about the application seeing a single IP, all you can really think about, again, the wavelength cannot initiate a connection to the mobile phone itself. So it's not really seeing anything. It's the mobile device initiating connections with the wavelength zone. And what it sees is the carrier IP. But of course, the carrier gateway is taking care of the natting between what you see and what the VPC sees and its corresponding private IP address. So the takeaway here being, yes, there's complexity. No, it doesn't really, the wavelength zone cannot initiate connections with the underlying UE, but the way that the carrier gateway was designed was so that you don't even need to answer that question. It's just abstracted for you.
Got it. So the second part of the question was, and I think you kind of answered this, which is, does your application see a single IP where all the mobile devices are accessing?
So the one-to-many relationship, if I'm understanding correctly, when you create a VM in a wavelength zone, there is a single carrier IP address that is allocated to that. Of course, you can allocate more than one carrier IP to a VM in a wavelength zone, but all of those mobile devices will see that single carrier IP.
Got it. Cool.
Yeah.
Good to know. Okay. There's another comment. Wavelength zones can't route to other wavelength zones, so then a distributed Kubernetes cluster won't work if the workers can't talk to other workers. They need a multi-cluster setup.
Yes and no. So we've been toying around with this for a while. Yeah, what that means is that if you've deployed your application in such a way where service A in edge 1 is reliant on service B in edge 2, then you're right, you can't. But the whole point of wavelength is that it's hub and spoke. So you shouldn't, and I've had many, many long evenings and weekends with the wavelength service team fighting this very point. And their response is, if that's what you've done, then you've made a poor architecture choice. If you're going from one edge to another, why not just sync back or connect back to a service that lives in the parent region? Again, it can still be you can have a cluster with node groups and all of the different AZs in the parent region and every single one of those wavelength zones. And data can be exchanged. So if I have an edge that needs to somehow sync with another edge, one, it's unlikely that it would actually, from a strongly eventual consistency perspective, it's very unlikely that one region needs to be fully in sync with another almost instantaneously because the data that's being generated are from two completely separate locations. But if for some reason you needed that anyways, think of, again, hub and spoke. You sync with your hub, and then the second edge can also sync with its hub. But it doesn't mean that you can't run distributed Kubernetes clusters. It just means you have to be really prescriptive about where services live. And one great example is Core DNS. So many hours of my life are gone because of Core DNS. And so one takeaway here is if you're running these like edge and non-edge simultaneously node groups within a cluster, make sure Core DNS is exclusively scheduled to the parent region. Because if not, then you're trying to resolve a service name from another edge that you can't talk to. So you'll never get an answer. So you'll never talk to that service.
Yeah. So someone made the comment about a node group per wavelength zone with the Kubernetes servers in the parent region. And then I guess, yep, there we are. And then we federate across, hopefully, or theoretically, we federate across Kubernetes clusters. I will say, I do favor the hub and spoke. I know Kubernetes tends to favor like a sort of a mesh federated model. Console works with more hub and spoke model as well. Seems like network, but at least the way this is set up is also favoring it. So I think we're always going to run into some discrepancies or some conflicts with the two types of architecture. So it's an interesting question. but it's one that I never thought about that would affect sort of how you would set up your Kubernetes clusters across all of these different kinds of setups and network topologies, right? All right. Okay. So I think that's the last question we're going to take for today. Robbie, thank you so much for joining us. I appreciate that you went through so patiently and talked to us about 5G in the shortest explanation and probably one of the clearest explanations. And I'll definitely clip that for later. And thank you for answering all of our questions.